As we stated in the previous video, some equations in mathematics are difficult to solve through standard operations. Instead, we would need to round the values either up or down to find an estimate of the exact answer. However, we must understand that each rounded number contains a different degree of accuracy. For example, although these three numbers are mathematically similar, their degrees of accuracy are completely different. 3.2, for starters, is rounded to 1 decimal place. This means that any number between 3.15 and 3.25 would all round to 3.2 corrected to 1 decimal place. These numbers are known as bounds, where 3.15 is the lower bound and 3.25 is the upper bound. What we notice as a general rule for bounds is to take plus or minus half of the degree of accuracy to find either the upper or lower bound. For example, if this number is to be rounded to 1 decimal place, we need to plus or minus half 0.1, therefore making the upper bound 0.30 and the lower bound 0.20. Let's say we had a plank of wood that was 26 meters long, corrected to 1 meter. To calculate the upper and lower bounds, we would have to find what half the degree of accuracy is, which is half a meter or 0.5 of a meter. Consequently, we would plus or minus this value from the initial 26 meters, giving us upper and lower bounds of 26.5 and 25.5 respectively. Now, it's also important to know how to calculate bounds within operated equations. Although the new syllabus directly tells us not to understand this concept, it is important to learn for future references, so therefore I will only briefly explain it. When operating on approximated values, it is important to try to find the largest upper bound or the smallest lower bound possible. For addition and multiplication, this is easy. To find the bounds of added approximations, you must simply add the upper and lower bounds respectively, while for multiplication, we multiply the upper and lower bounds respectively. For subtraction and division, on the other hand, we need to use more intuition. Let's say we have values a and b, and we want to find the bounds of these values when subtracted and divided. If written like this, to get the highest upper bound when subtracting, we need to take the upper bound of the largest number, or a, and subtract the lower bound of the smallest number, or b, from it. This is the same for division, written in this form. In the same way, for the lower bound, we would need to subtract the lower bound of a with the upper bound of b.